So, good morning, students. So, in the last lecture, we have seen about your 8-point DFT. Okay. So, your 8-point DFT and your 4-point and your 2-point DFT we have seen. And in today's lecture, we'll be seeing some of the special cases. Okay. So, what are those special cases means? So, I said in your DFT concept, your Radix is there, right? So Radix is be based upon. So your Radix is what which determines your uh, whether the number of points of the DFT. Okay. So regarding this Radix, I have given in the previous lecture. So you just refer to the previous lectures. Okay. So in today's class, we will be seeing the special kind of Radix. That is your 2-point, comma 4-point, comma 8-point. So these all belongs to radix of 2. Why in the sense means these radix and all you can what you can say you can show in the form of exponential of 2. Sorry, in the powers of 2 we can bring it out. That is, if it is a 2 power 1 means it is a 2.1 matrix. So 2-point DFT, and if it's coming to the 4 means 2 square, and similarly for an 8 it is 2 cube. Okay. Similarly, in today's topic, we are going to see about a special case. So just nothing but a DFT of different radix. Okay. So here we can first get into some of the generalized format. Okay. So today we'll be saying about the radix of 3. Okay. So we'll be saying for the radix of 3. Okay. So this is a rare case. In terms of problems, sometimes only they'll be asking in this segment. Okay. So we can first get into your generalized format. Okay. Okay. So here your concept differs. Okay. How it differs, I'll be saying. So can I get started? So I'll be getting the example, then you'll be getting some idea. So example number 2018. Okay. Okay, given is that, and then given is that signal x of n. Okay, x of n. Okay. So it belongs to 1 comma 1 comma 1 comma 2 comma 2 comma 2. Okay. So now here the number of samples n is 6. Okay, n is of 6. Okay. So what they ask me to find is that here they ask me to find or to develop the creative FFT algorithm. Okay, creative FFT algorithm creative FFT algorithm for flow diagram of n equal to 2 cross 3. Okay. They are asking to find about this thing. Okay. So what you can do? So till now we have dealt with the n of n equal to 8, n equal to 4, and n equal to 2. But here it comes with respect to n equal to 6. So if it is coming with respect to n equal to 6, you can take it as radix 3. So the radix coming under over here is of 3. Okay. So based upon this, here, the only difference is that your triple factor and the structure varies. Structure of your DFT diagram varies. Okay. So we'll be getting into this. So here they have asked you to solution. You can just take it solution. They have asked you to decompose into n equal to 2 plus 3. Okay. So this refers to p comma p into n. That is, your x of n will be decomposed into into two sequence two sequence, okay, with each sequence of with each sequence of three samples, each sequence of three samples. So that is what your 2 cross 3 implies. Okay. So in general, the formula what we can write is the formula for this how it will be means x of k is equal to summation n equal to 0. Okay, this is the basic formula to 2. X of this 2 represents your p value. This 2 represents your p value. X of 2n into w 6. This 6 refers to your n value. Okay, in the whole for 2n k plus summation n equal to 0 Okay, n equal to 0 to 2 x of 2n plus 1. Okay, one refers to your odd term and another one refers to your even term. This is what I was telling you about in the starting of your FFT concept. Okay, so it is nothing but the summation of your odd part as well as your even part. W6 2n plus 1 into k. Okay, so now what happens? We can take this triple factor outside. Okay, so the difference between this and this. Okay, the difference between this point and this point is that one W6 of k is in excess in this part. So this you can write it as, how you can write it? This becomes summation n equal to 2, 0. The first term will be the same. 2x of 2n W6 2n k plus W6, okay, W6 of k into summation n equal to 0 to 2 x of 2n plus 1 into W6 2n k. So this is the same thing. Okay. But here there's one 2n plus 1 is there. So this you have to define. So here there will be two terms. So x of k will be equal to x1 of k plus W6 of k into x2 of k. So here your k value will be, k will be taking the value of k equal to your k will be taking the value. What value it takes? It takes from 0. That is k will be equal to 0 to n minus 1. So it will be taking the value of 0, 1, 2, 3, 4, 5. Your n value is 6. Okay. So it is 6 minus 1. So now we are dealing with the W6. Okay. So now we have to find your W6 of k. So put W6 of 0 will be getting e power minus j 2 pi by 6 into 0. So it is equal to 1. Okay. W6 of 1, which is equal to e power minus j 2 pi by 6 into 1. So this we can write it as cos pi by 3 minus j sin pi by 3. So this contributes to 0.5 minus j 0.866. Okay, this is your W61 value. So followed by your W62. W62, it will be e power minus j 2 pi by 6 into 2. Okay. So now you just, this becomes cancel, becomes 3. So now what happens? It will be the same thing, but the sign varies. Okay. So it will be minus 0.5 minus j 0.866. Next is W6 of 3 will be equal to e power minus j 2 pi by 6 into 3. So you get, here this goes and this goes and this goes. So it will be e power minus pi, so it is minus 1. Okay, next W6 of 4. So this goes to the same, but the sign varies. It will be equal to minus 0.5 plus j into 0.866. Okay, then W6 of 5, which will be equal to 0.5 plus J 0.866. I think you're clear with this. So these are the triple factor values which you have to know in order to find using the butterfly diagram. And now we'll be getting with respect to your each part. Okay. So as I said, it has two stages, two stages, three samples. Okay. So here we are going to find with the each stage. Okay. So first I will draw the butterfly diagram. Then I will be moving to your what can I say? Then I will be moving to your other part. Okay. We can start with this. First, as I said, this side it will be your inputs, and this side it will be your outputs. Okay. So your input is x of 0. First, you have to group it by your odd values, x of 2, x of 4, and then x of 1, followed by x of 3, followed by your x of 5. Okay. So this is one thing, and at this side it becomes x of 0, x of 1, x of 2, so x of 3, x of 4, followed by x of 5. Okay. So next we have to draw the line. So now we have drawn the line. So here, as I said, it will be of two stages or three samples. Okay. So how it will be? Two stages I said. So this input will be traversing two stages. So this is the final stage. So intermediately there will be another one stage. So which is given by x1 of 0, x2 of 0, x3 of 0, sorry, it is x1 only. Here it is. So it is x1 of 1, it is x1 of 2, it is x2 of, so x1 only. So x1 of 3, x1 of 4, followed by x1 of 5. Okay, so this is what you are really getting. And now other things are the similar. You will be connecting similar to a 2.8 this point to your this point will be connecting. And here to here will be connecting. So each of the stage will be having three samples. So if this is one stage, right, so it will be traversing 3 points. So it will be having like this. So this will be again going to over here. Okay. So this one is connected with this, and this one is connected with this, and this one is connected with this. So it will be having 3 points. Okay. And similarly here, this will be connected with this. Okay. So like this it will be, and over here it will be the triple factor value will be W 6 of 2. Okay, this W 6 of 2 will be again repeating over to the here. Similarly, this repeats over here. Because you can draw that decomposition lines. So I say that for each point, 3 lines will be coming. So this will be getting with this, and this will be getting with this, and over here, this will be getting with this, and this will be getting with this, and over here, it will be getting with this end to this end, and then this end to this end. Okay. So I hope you're clear, right? Okay. Now, taking factor for this stage. So here it comes. So triple factor will be the same W6 of 2, and over here again it is W6 of 2. So here I just made around this type, and this is the second sample. So here it comes x2, x2, x2. Three samples. This is one sample, this is two samples, so we'll be getting the output. Okay. So two stages. So this corresponds to the two stage, first stage, and then the second stage. Okay. And now what the next part? You have to connect this. So here also same. Each and everything will be connected in terms of this in this fashion. So this will be connected to the here. Okay. This will be connected to here. And this is only 3 point volts. Okay. So it will be like this. Okay, like your triple factor starting from the lower part. So it is W6 of 5. And here it is W6 of 4. Over here it is W6 of 3. So this will be changing to 1, 2, 3, 3. It will be 1, 3, 2. This will be 3. Okay. Okay. Wait, okay. There is the diagram. Okay. And this part will be okay. So this is your diagram, and here. So I'm just having one small doubt over here. This x of 2. So whether there will be a triple factor coming over there, I don't know. I think it will be coming. So okay, we can just solve it. Then we will be getting the clear idea. So wait, I'll be just making it with some theoretical calculations, so that you may be understanding somewhat in an easy manner. Okay. So okay. So first we have seen about your triple factors. Okay. And now we getting into this part. Okay. First your x1 of k. Okay. This will be equal to summation n equal to 0 to 2. Okay. X of 2n w6. Now we will be using the butterfly diagram. We can also do it in the theoretical manner. Okay. So if you are doing in the theoretical manner means, so first here you are taking for the even signals. So this is an even signal. Okay. So here we will be only applying the even signals. So what are the even signals? X of 0 plus x of 2. Okay. Here n equal to, you have to put n equal to 1. Okay. So n equal to 1 you have to put. So then it becomes w6 2 into k. Okay. Plus x of 4 w6 x of 4 w6 4k. Okay. So this is what you'll be getting. And now in this you substitute the k values. Okay, this you have to substitute the k values. K equal to 0, comma 1, comma 2. Okay, so this will be corresponding to your this stage. Okay, x1 will be corresponding to your this stage. x1 of 0, x1 of 1, x1 of 2. So you'll be getting these values. So now what happens? You have to put x1 of 0, which will be equal to, okay, you just put the 0. So you'll be getting x of 0 plus x2 plus x4. So this will be equal to 1 plus 1 plus 2, which is equal to 4. So this is your x1 of 0 value. This will be correspond to your x1 of 0 value. Okay, so this is how you can find the theoretical part. Okay, so next moving on, x1 of 1, which will be equal to x of 0 plus x of 2 w6 of 2 plus x of 4 w6 of 4. Okay, and now we have to apply each and every value, that is w6 of 2, w6 of 4 will be applying for the k value 2. Okay, so now this becomes x of 0 value is 1 plus 1 into minus 0.5 minus j into 0.866 plus 2 into minus 0.5, okay, plus j into 0.866. Okay, so this becomes minus 0.5 plus j into 0.866. Okay, this is x1 of 1. And next x1 of 2 will be x of 0 plus x of 2 into w6 of 4 plus x of 4 to w6 of 8. Okay, so this becomes x of 0 plus x of 2, okay, w6 of 4 plus x of 4 w6 of 2. So this 8 you can just take it in this manner because it is in the unit circle, so it gets repeated. It gets in the repeated manner. So your 8 value becomes 2. Okay. So now this becomes 1 plus 1 minus 0.5 plus j into 0.866 plus 2 into minus 0.5 minus j 0.866. We'll be getting x1 of 2 as minus 0.5 minus j 0.866. Okay, so now we have completed for the 3 samples. Okay, still there are another 3 samples. So it will be contributing to x2 of k, which is equal to summation n equal to 0 to 2. Okay, so this is for the even signals, sorry, odd signals, x of 2n plus 1 w6 2n k. So now this will be equal to x1 plus x3 w6 2k. So n value we are putting 1 plus x of 5 w6 4k. Okay, so because why I am putting n value 1 means n equal to 0, everything will be 0. Okay, so if it goes up to 2, so it will be the intermediate value is 1, so you'll be getting up to the 1. So now your x2 of 0 value will be x of 1 plus x of 3 plus x of 5, and this contributes to 1 plus 2 plus 2, which is equal to x2 of 0 will be equal to 5. Okay. Next, x2 of 1, this will be equal to x of 1 plus x of 3 w6 of 2 plus x of 5 w6 of 4. Okay. So this will be equal to 1 plus here 2 comes out because w6 of 2 value into w6 of 2 value. X of 3 is 2. So minus 0.5 minus j 0.866 plus 2 minus. So if you're doing theoretical calculation means you can just take it similar to that of your, what you can say, you can take it as similar to that of your iteration methods. So in the iteration Newton-Raphson method, we'll be doing like this, right? So the same thing. So plus j into 0.866. So this will be equal to minus 1. So x2 of 1. So if you're feeling the butterfly diagrams difficult means you can just carry out in this manner. Okay. So then x2 of 2 will be equal to x of 1 plus x of 3 w6 of 4 plus x of 5 w6 of 8. So as I said, the 8 you can represent in w6 of 2. Okay. So now what happens? It becomes, this will be getting 1 plus 2 minus 0.5 plus j 0.866 plus 2 into minus 0.5 minus j 0.866. Okay. This will be getting the values minus 1. Okay. And now how we can contribute, how we can get a decomposed to the final step means x of k will be equal to x1 of k. That is the intermediate stage plus w6 of k. So this is what we have seen at the beginning of the solution, okay, into x2 of k. So now we have to formulate step by step. So x of 0 you have to put k equal to 0. X of 0 will be x1 of 0 plus x2 of 0. So we'll be getting 4 plus 5, which is equal to 9. Okay. And next x of 1 is equal to x1 of 1 plus w6 of 1 x2 of 1. So this becomes x of 1 will be minus 0.5 plus j 0.866 plus the same value, but the sign differs, 0.866 into minus 1. So we'll be getting minus 1 plus j 1.732. Okay. And next for your x2 will be equal to x1 of 2 plus w6 of 2 x2 of 2. So we'll be getting minus 0.5 minus j 0.866 plus minus 0.5 minus j 0.866 minus 1. So this and this are same, around minus will be coming, so x of 2 will be getting as 0. Okay. And moving on, x of 3 will be equal to x1 of 3 plus w6 of 3 x2 of 3 equal to x1 of 0 plus w6 of 3, x2 of 0. So substitute the values, we'll be getting 4 plus minus 1 of 5. So that is 4 minus 5. So we'll be getting minus 1. So still two samples are there. X of 4 equal to x1 of 4 plus w6 of 4, x2 of 4. Okay. This equal to this x2 of 4, how you can write means the x1 of 1 because it gets repeated. So w6 of 4 will be the same, but x2 of 1 you can just take it out. And now this becomes minus 0.5 plus j 0.866 plus the same value minus 0.5 plus j 0.866 here into minus 1. So we'll be getting 0. So for the last one, x of 5. X of 5 will be x1 of 5 plus w6 of 5 into x of 2. x2 of 5. So x2 of 5. So we'll be getting x1 of 2 plus w6 of 5 to x2 of 5. Sorry, x2 of 2. And this becomes minus 0.5 minus j 0.8666 plus the same value 0.5 plus j 0.866. The difference is that minus 1. We'll be getting minus 1 minus j 1.732. So here, how we are writing this means at the beginning I have to say that there's some relation. So this we can take like this: x xi. Okay, here I write. So xi of k plus 3 will be equal to xi of k. So based upon this relation only, this step to this step conversion is taking place. Okay. So now he has got all the six values. So now we can write it as dft x of k will be equal to 9 comma minus 1 plus j 1.732 comma 0 comma minus 1 comma 0 comma minus 1 comma minus 1 minus j into 1.732. Okay. So this is a kind of different problem, but this is how the theoretical part is built in this. Okay. So in the last two lectures, I have just covered with your butterfly diagram. So in this part, this is the meaning of your butterfly diagram. Okay, the theoretical part. Okay, so this is the theoretical part. And how we are getting the samples of each and every part of the butterfly diagram is shown over here. Okay. Uh, yeah. So this is how we can formulate. Okay. I hope you have understand somewhat the difference between the previous lectures and this lectures. Okay. So this I think we can stop this lecture. Okay. So thank you.